Welcome to the session of engaging with ITU-T SG15 for building the world digital backbone. So in these presentations, I briefly covered the introduction of the Sterlite technologies, STL, and I will also introduce the SG15 and its activities, and I'll share our experience that how we are engaging with SG15 based on our business operations and the product line. So it begins with this, the importance of the standards. So we come across various quotes regarding the importance of the standardization of the standards. Is one of my favorite quotes is that when things do not work as they should, it often means that the standards are absent. To make the future predictable, so we need to build standards what we want based on the technological advancement and the application needs. So let's start with the introduction of the Sterlite technologies, STL. So STL is a leading global optical and digital solution providing advanced offering in the 5G, rural, FTTX, enterprise, and the data center network. So we have three verticals and three customer segments like telcos, cloud companies, citizen network, and the large enterprises. They rely on the STL advanced capabilities in optical connectivity, global service, and digital and technology solution to build future-ready digital networks. So we have three verticals of business units, that is optical networking business from where I am. So we'll mainly focus on these verticals which deal with this product line like optical fiber cables, specialty cables, and optical connectivity solution. So the company driven by its purpose of transforming billions of lives by connecting the world, designs and manufacture in 4 continents with customer in more than 100 countries. So STL business goals are driven by customer centricity, research and development, and sustainability. All our manufacturing plants in India and Italy are the zero waste to landfill and zero liquid discharge certified. So we are also focusing on this, the SDG goals of United Nations. So this is more about the optical networking business. So we are the 30-year young optical fiber and digital solution company. There is a great probability that the optical fiber that reaches you is either made by us or deployed by us. Let me tell you one of the interesting point about Sterlite. That STL is the only company in India and among few others globally that have a capability to manufacture the optical glass preform. And this is not a optical glass preform. The key raw materials to manufacture glass is also manufactured in-house. So you can see we have plants in different locations, optical fiber plants in India, the glass preform manufacturing plant, optical fiber drawing facility in India and China, optical fiber cable manufacturing facilities in India, Italy, Brazil, and USA, and optical connectivity products manufacturing facility in India and Italy. So that's all about this. Next, come to this how we participate and how we see the telecom standardization's engagement circles. So we engage with international and the national standard development organization. And international, we are the sector member of ITU-T since 2007, and we participating mainly in the SG15 activities because it is aligned to our product line. And currently, we have 3 leadership roles and 2 editing roles in SG15. Next important SDOs that we are engaged, that is the International Electrotechnical Commission or IEC, and we are the member are engaging since 2014. We are engaging with this mainly technical committee 86, that is fiber optics, and its subcommittee SC 86A, optical fiber and cable, and 86B, that is deals with passive components. So our expert from India and Italy so far lead around 14 standards, 14 IC standards. In the national level, we are engaging with Telecommunication Engineering Center, that is a technical wing of Department of Telecommunication India. We are the member of the transmission and the fixed access divisions. Transmission division really developed the standard for the fiber and the cable specific to the country requirement. and fixed access division developed the standard for different passive components. We also member of the National Working Group 15. So in India, we have a mirror committee of all the study groups of ITU. Like National Group 15 is a mirror committee of study group 15. So we also engage with the National Working Group 15 to contribute in ISC study group 15. Next is the Bureau of Indian Standard. This is a National Committee of India Standard Developments. As TEC engage with ITU, similarly BIS engage with ISC. So we have a mirror committee in BIS, that is LITD 11, that is a mirror committee of IEC TC 86, that is fiber optics. So also we engage with BIS LITD 11 committee to participate in the ISC standardization activity. So in the right side, we just demonstrate that this how standardization process starts and ends, and this is a kind of a cyclic process. So it starts from the needs of the technology and the market, and when we gather the customer requirement, market requirement, and technology advancement, that all feed into our product line strategy, and product line strategy then feed the requirement to our research and innovation department, and then research team collaborate with different organizations, within the organizations, even the outside organization, with our partners, vendors, even with the academic institutions to initiate the research programs. And output of the research is like a research papers, conference paper, journals, patents, and the mature state it becomes standards. So when we develop standards, then we certify our product based on the standard, and then we access the market with the certified product. And again, when we go to market, again we see what is the next changes required, and again the market trends we capture, and again it fit through the product line strategy. So this is a cyclic process of the standardization, starting from the market needs and end with the market needs, and again it's started from there only. Okay, so now what is the engagement cycle with ITU? So this is a two-way circle. One side you are implementing, another side you are contributing. So as you are sector member of ITU, we are, and also this, of course, the ITU standard, you know, this is a freely available standard, you can download it, and we are implementing the ITU recommendations, supplement technical reports in different operations, like in research, in manufacturing, in quality assurance, certifications, sales, even the supply chain. And another way, when we implement the standard, if we find some another opportunity for improvement, we feed back to the ITU as a part of contributing or contributions, whether it is a revision of the existing standard or even the development of a new standard which is not exist anymore. So the two ways we can contribute. So as a sector member, we can directly contribute to ITU-T, or we can contribute to the National Working Group, and then along with the National Working Group members' view, we can jointly contribute to the ITU, the two ways. So this is implementation and contribution, the two way we can engage with the ITU. Okay, so next comes to the study group 15. So what we see here, that is a optical infrastructure that we call the world digital backbone. So this map is available in the ITU connectivity infrastructure maps, and we can see two lines here. Thick blue lines, that is basically the optical fiber cables connecting different countries within the countries, and the light green lines are the submarine on the underwater cable connecting different continents, island, and the coastal areas. So whatever the technology that we are hearing nowadays, that is the AI/ML, metaverse, quantum, IMT 2030, 6G, all are based on this backbone. So study group 15 is developing technology and standard to strengthen this world digital backbone. So what study group 15 is responsible for? The development of the standard for optical transport, optical access, and home network, and also the power utility network infrastructures. So it also develops standard for the equipment, the maintenance systems, management, test methods, instrumentation, and the measurement techniques, and so on. Okay. So where ITU stand? ITU under study group 15. So these ITU structure and organizations. So ITU, the highest level is the plenipotentiary conference, and then ITU council. Then you have three verticals of ITU: ITU-R for radio communication, ITU-T for development sector, and ITU-T for standardizations. So again, ITU-T, and then you have a WTSA, the event is going on now. Then you have a TSEC, telecommunication standardization advisory group, and under that you have all the study groups. And then another study group we have working party. Working party is kind of a technical committee, and then question is kind of a subcommittee. It deals with the specific topics. Then we have this leadership team of ITU, doesn't need more introductions, and we have a leadership team of ITU study group 15 who is appointed during WTSA 20 that happened in March 22. Now we have a Mr. Glenn Person who is the study group 15 chair. Then this is the study group 15 management team for this study period 22 to 24. You can see the vice chair. So currently I am one of the vice chair of study group 15. And study group chairs appoint the vice chair and chair of the 3 working parties. And then we also have a promotion and the coordination committee, with is a kind of a deal with all the liaison that we receive and coordination within the study group 15 and also other study groups within ITU-T and outside ITU-T. Then we have a TSB advisors, Mr. Hiroshi, Mr. Araki, and Ms. Emmanuel. So this picture taken during the last plenary meeting in July this year. It was in Montreal, Canada. That was the first time the study group 15 met outside Geneva. So now what I mentioned, the study group 15 deals with network, technologies, infrastructure, transport, access, and home. So this is the entire domain of study group 15 work. We start from submarine, then it's the core and long-haul ultra-home network, metro aggregation, access, and home network. The 3 working parties, the working party 1 focuses on the transport aspects of access, home, and smart grid. Working party 2 focuses on optical technologies and the physical infrastructure, and working party 3 on transport network characteristics. So these are all the questions under the working parties. So working party 1 is, as I mentioned, is the coordination of access home network, then optical system for access network, technologies for in-premises network, and broadband access network. So you have highlighted, I have highlighted the question working party 2, that is 5, 6, and 7, and 8 questions. So these are the questions mainly as a Sterlite we are focusing on because it's related to our product line. For example, the question 5 is the characteristic and the test method for the optical fiber and the cables and the installation guidance. Question 6 for the system for the transport network, and question 7 for the connectivity, operation, and maintenance of the optical physical infrastructure, and question 8 deals with the optical fiber submarine cable system. And working 23 mainly work on the different characteristics of networks like signaling, synchronization, and all those points. So here we'll share our the study group 15 deliverables. There is a 4 deliverables. We have a recommendations, that is basically standards. This is a normative document. Then we have a non-normative document like supplements, technical papers, technical handbook, or technical reports. Then also study group 15 develop flyers. Flyers is basically just a 1-pager to give a very overview or highlighting the work that we are doing. Generally we develop flyers when we develop a new standard or do some major changes in existing standards. So all the recommendations that study group 15 deals, mainly the G series recommendations, G series supplements, and L series recommendations and L series supplements. Here are some number of study group 15. Light blue at the top lines is the basically study group 15. So it actually what indicates that study group 15 is the most popular standards in the industry based on the number of download. And you can see the number of download based on the working parties. The working party 2, G.652, the single mode optical fiber standard, that is the most downloaded standard among all the standards published by ITU-T, and it is consistently the number 1 for a long period of time. Then we have a G.719, that is working party 3, and G.984.3 working party 1, that is for the GPON system. And we have a many work item is going on study group 15 over 270 work item. You can see a statistics here based on the different questions. Study group 15 also collaborating with other standard development organizations. You can see a long list of standard development organizations where we are receiving or sending a liaison statement, like IEEE is the number 1, then Broadband Forum, OAF, and IEC. And IEC is another important study group based on the Sterlite that we are, because it is close to our product line, and currently I am one of the liaison rapporteur of for IEC SC86A for optical fiber and the cable. So this is our experience in the standard development or agreement bench process. We call it the 5 C's, and we come across these 5 C's very often when involved in the standardization process. So I'll start with the contribution. So ITU is a contribution-driven organization. So contribution is basically to initiate the standard development process, research, and basically the research outputs. And so when you contribute, the second will be the collaboration. So when we collaborate with the fellow members within the questions, within the working party, even with the other standard development organizations, by formal and informal discussion with the members to let them know about the contributions. The next stage is the consensus. So this is an inclusive process, and these views of all stakeholders are considered. Again, ITU is a consensus and driven organization. It is a general agreement between the experts whether we approve or disapprove a contributions. And next is the consent. That is the last stage of standard development process. So generally the consent is taken during the plenary meeting of working party and the study group. So theoretically, this is actually not the last stage. After that, there is one more process is there. It is called the alternate approval process, or AP, or TAP, traditional approval process. So this is a process where again the document is published for any comment from the member state. But once it is consented a document in the plenary meeting, so most of the time it is approved. And the last C, I can say, the certification on the conformity assessment. So this is actually implementation of the standard. So when we publish a standard, we want this standard to be implemented in the real life. And for that, we need to certify the product and solution based on the standard. So there are various examples of the product and certification. Like India, we have a ISI certifications or MTCT certification, that is mandatory testing and certification for the telecom equipment. And also ITU also promote this certification and also started recognizing the testing laboratory called ITU recognized TL for interoperability testing and the certification of based on the ITU standards. So I will come across now, I will touch few of the work that we engaged particularly with the working party 2. The first one is a technical report on optical fiber cables and systems. So this first revision since 2015 and it is agreed in this year plenary meeting. The purpose of the revision work was to review and update the 11 chapters of the TROFCS with the latest technologies and ITU publications. And this revision work include all the recommendation published by working party 2 questions, that is question 5, 6, 7 and 8, and were revised by the rapporteurs and editors. Almost I think 14 or 15 editors works for 1.5 years to revise this technical report. And this tier addresses the practical issues associated with the application of optical technologies, explaining how ITU recommendation address them. And what was also it intends to make the scientific community aware of the factors that drive the optical infrastructure development. So this is not only a compilation of the recommendation, it also adds a lot of history how the technology evolved from 1970s to today and in the different phase wise. This document is a very useful document to understand what our activities going on to, even it can be used as a education purpose also, particularly for the newcomer to the industry. Next, I'll touch upon the optical fiber recommendations, that is the ITU-T G.65X series of document. So the map I shown in the previous slide, the map connecting all the countries, components, all are basically the G.65X series of optical fiber cables. So in this year, the last plenary meeting, question 5 of study group 15 has published the 10th revision of G.652. In fact, we are celebrating the 40 years anniversary of G.652. It was first published in 1984. So the 10th edition is updated with some marketing, the application needs. The new version adds the information on the statistical chromatic dispersion properties in multiple fiber segment links, where 7 fiber manufacturing share the data, and Sterlite also participated in these discussions. This is one of the example of collaboration, because these studies collaborated with the 3 question 2, question 6 and question 5, and also IEEE 802.3. And this methodology that we included in this latest version of JSON 652 is expected to support the future deployment or development of the faster IMDT transmission systems. Second revision we published the JSON 657, and that is the fifth edition of JSON 657 that is getting a lot of importance and popularity in the telecom network. Initially it was developed to address the access network. Now it is being utilized throughout the terrestrial networks where bending loss in sensitive fibers are required to achieve installed performance requirement like data center applications or high fiber density applications. So here on the example how we implement ITU recommendations. This is one of the fiber that we developed and even we launched in IMC Indian Mobile Congress 2019 that comprise all the properties of 3 ITU recommendations, G652D, G657A1 and G657A2. All 3 combined to address some application challenges. So third standard I want to touch upon the space division multiplexing. That is another hot topic in ITU-T. The study group 15 first time published a technical report on space division multiplexing. This is basically increasing the number of transmission channels because new technologies are evolving. It needs more data, more bandwidth, and current fiber may not support those needs. So that's why the study group 15 is working on these space division multiplexing technologies. So there are the 4 type of fibers we are talking about here: reduced coating, reduced cladding, multi-core fiber, and the few mode fiber. Now, question 5 of study group 15 is working towards a framework to guide the standardization activities, how to make a progress, because this is a very complicated task to develop the standard of a new fiber because it involves a lot of other components as well. And also it is collaborating with the IC organization 86A, SC 86A, B and C, because most of the test methods are developed by IIC and ITU, the referred test method. So it's a close collaboration work is going on between ITU and IIC. So here I will give the 2 examples that as I mentioned that we have 2 ways we can contribute in ITU as the implementing and contributing. So one side we implemented the ITU by developing a high density cable. You can see the bottom right picture, that is a 6912 fiber, the high density cable. It is compliant to various ITU and IC recommendation like ITU G657A2 fiber, 200 micrometer diameter fiber, partially bonded ribbon, and various L-series optical fiber cable recommendations. On the right side, you have a multi-core fiber, which is standard is still under development. So we are sharing our experience and our the designs of the multi-core fiber with the study group 15 to help to develop a standard on this SDM technology. So one side we are implementing the standard, and other side we are contributing to develop a new standard. So this is one of the pictures. It is I've taken this from picture from this ITU recommendation L.250. So this is a recommendation for the access topologies. You can see that a schematic diagram starting from OLT to ONT, and these access technologies have all the components like branching components, cables, and so forth, And you can see that ITU study group 15 developed at least one standard for each and every component. So we wanted to get to knowledge about any component. You just download this particular standard, you get to know about this particular component, you can implement it, you can contribute it. So study group 15 basically compile all the industry knowledge, research knowledge, and publish the recommendation to help to implement the various network elements in the telecom, like access network, even similar standards available for the transport network as well. I just invite my colleague Dr. Anisha Maiti just talk about the judo DFS system that she is working on.
Thank you, sir. So, hello everyone. So I'll briefly touch upon the Sterlite's activities in this area, the distributed optical fibers sensor. So basically we all know that the optical fibers can transmit huge amount of data, but do we believe that the fibers can also behave as sensors? So this particular thing is known as the distributed optical fiber sensing, where the entire fiber length can act itself behave as a sensor. So there basically the principle is that the light which is being guided, that is very sensitive to the ambience like temperature, strain, vibration, etc. And hence by detecting the changes in the light properties, we can detect the presence of these disturbances. So basically the distributed optical fiber sensor can comprise almost tens or thousands of point sensors along the entire, like we can replace tens or thousands of point sensors, and we can use a single fiber in place of them. So that's a like a kind of huge quantity we can achieve and take the advantage of. So basically, yeah. So basically the new hot topic in the ITU is the standard for the DOFS, and the basically where the covered areas are, just excuse me, I couldn't see that. So the covered areas are listed here: the DOFS light source, the optical interrogator, the assignment of different wavelengths and channels. So these are all the covered areas, and here the mainly for the distributed optical fiber sensing, two techniques have been used till now. One is the back scattering type, where the light gets scattered back from the scattering centers inside the fiber core. So some schematic has been shown on the right hand side, where it is showing that the light getting scattered, and the back scattered light is getting processed in the detector hardware. So basically here the backscattered light can be sensitive to the acoustic vibrations, so on which Sterlite is working on, and the acoustic vibration can modulate the phase of the light, and by detecting the sent and the received versions, we can just find out the presence of any acoustic vibration there. And there is one more technique, is called the feed forward type, so we are not going into that now. So in Sterlite, since last few years, Sterlite has been working on the distributed acoustic sensing solution. So here the R&D team has achieved the single channel sensor, which can be used as a the surveillance kind of thing for a over the range of 40 kilometer, and if you use the dual channel, the achieved range has been increased to 80 kilometer. So this is basically a single core sensing, and both the buried and aerial versions have been tested. And also, like we have also worked with dark and live fiber as well. So basically this kind of sensor, the DAS or distributed acoustic sensor, has been targeted for the applications like the perimeter protection, the border surveillance, as well as critical asset guarding. So this kind of things are will be benefited. This kind of application areas will be benefited from this sensor. And going forward, I'd like to say that Sterlite will like to be actively participating in the this, based on their experience, whatever they have gathered in the sensing solution development. Based on that experience, Sterlite would like to actively participate in the also in the standard development of this G.DOFS. Thank you.
Thank you, Anisha. So this is the last slide, that is the ITU recognized laboratory. As I mentioned, that the last C of 5 key C's of standard engagement process is the certification and the conformation assessment. So we have two testing laboratory to test optical fibers of G series recommendations, that is now recognized by the ITU-T as a ITU-T TL database, and where you can test and certify the optical fibers, and also perform the interoperability testing. So that is our, we believe that the standards are the key to link technologies with the market, and developing standard means designing the sustainable futures. So thank you for your attentions. Namaste. Okay, thank you.